A number of my students have been asking about how to solve certain word problems that involve linear models given 2 points or 2 data points and trying to find an equation that models the behavior of that data. Here's an example that I wanted to walk through to kind of illustrate how to pull out the information that you need from the word problem and then break it down to a basic algebra solution. So, for example, here we have an on-demand publisher. They charge $22.50 to print a 600-page book and $15.50 to print a 400-page book. Now, before we go into the algebra part of it, let's just sort of try to make sense of what's going on. You have an on-demand publisher, which means you tell them you'd like them to print something for you. And for a 600-page book, it'll cost $22.50. And for a 400-page book, it'll cost you $15.50, which makes sense. More pages, higher cost. So this is kind of like having 2 points, and we're going to be asked to find the equation of a line. And these points are cost, C, and the number of pages in the book, P. And this is our first cost. This is our first number of pages. This is our second cost, and this is our second number of pages. And then we're going to be asked to interpret things within a context. But let's get to that bridge when we need to cross it. So we've got C equaling the cost to print a book, and P is the number of pages. So the cost depends on how much our number of pages will be. So in effect, we have our pages are like X, and our cost is like Y. It might help us to think of it in that context as we go through this. The points on this linear model are of the form P comma C, or like I said, X comma Y. And since the cost depends on the number of pages printed, similar to how Y depends on X in a linear equation like of the form Y equals mx plus b. So we're given in the problem 2 different points or 2 different data points. We're given P1, C1, as I indicated up top, is 600, 22.5, and P2, C2 is 400, 15.5. Now, a common mistake that my students will make is they'll get these mixed up. They'll flip the order in which they have 22.5 first and 600 second because they saw this number first in the word problem. And again, it helps to pull back and remember the context that X is the starting point. The number of pages will tell you how much your cost is. So if you say, I need a 300-page book, your cost will depend on how many pages you've asked for, like 300 pages. If you say, I need a 600-page book, they'll tell you the cost is $22.50. So the first value you put in is you request the number of pages, and the publisher will tell you how much the cost is for those pages. So to find a linear equation, the familiar y equals mx plus b is going to be interpreted for our purposes as C cost equals slope, m, times p, the number of pages, plus b. So it's still a y equals mx plus b format, but in this case we have C and p as our variables. And this m and b will be filled in with numbers once we figure out what the slope and the y-intercept are. So for us, the slope is the change in y values, or the C2 minus C1, over the change in x values, P2 minus P1. And if we just plug through and evaluate, we end up getting the slope is 0.035. And this is in dollars per page. So the slope means it's about 3.5 cents or 3.5 cents per page of cost to print. So to find the equation of the line, you're going to go back and use the fact that you have the slope, and you're going to use a point, and this is what we call the point slope form, where this is going to be a number, and P1 is going to be a number, and M is a number, and the P and the C will remain letters. So if we use C1 as 2250 and P1 is 600 and our slope as 0.035, then we distribute the 0.035 through the parentheses, and we get C minus 2250 equals 0.035 P minus, and then 0.035 times 600 is 21. You can use a calculator to find that if you like. And if we add then 22.5 to both sides, we get on the right-hand side, these cancel. So we have C equals 0.035 P, and then this simplifies to plus 1.5. So now they ask us at the end to interpret the slope, which we've done right here. It's the cost of dollars per page. It's about 3.5 cents per page. And interpret C of 0, which is what you get when you plug in 0 into the original equation. And that means there is a fixed cost or a set cost of about $1.50 for just asking the printer or the publisher to do something. There have been no pages that have been printed, but there's an upfront cost. That might be for materials like paper. It might cover a little bit of their advertising cost. It might be the cover or the binding, but that's an initial cost before they've done any printing. So I hope this helps. If you've got any questions, feel free to post them below the video, and don't forget to subscribe or like if you thought this was helpful.